Welcome to our video, where we explore the exciting world of artificial intelligence. From advancements in machine learning to the latest developments in natural language processing, we'll take a closer look at how AI is shaping our world. As you watch, remember to subscribe and like our video to support our efforts in bringing you the latest and greatest in AI research and development. Your support helps us continue to create cutting-edge content and make the most of the technology of the future. So sit back, relax, and enjoy the show. AI engineering principles refer to the fundamental concepts and practices that are essential for developing and deploying artificial intelligence (AI) systems. These principles are the foundation upon which effective AI engineering is built, and they govern the design, development, and deployment of AI systems. In this article, we will explore the key principles of AI engineering. Problem identification and formulation. The problem identification and formulation stage is critical to the success of an AI engineering project. This stage involves understanding the business context and the needs of stakeholders, and identifying a problem that can be solved using AI. The problem must be formulated in such a way that it can be addressed using AI techniques. This requires a deep understanding of the problem domain, as well as expertise in AI. The problem formulation stage involves defining the task that the AI system will be solving, identifying the input and output data, and specifying the success criteria. The success criteria are critical to determining the effectiveness of the AI system. They should be well defined and quantifiable, and they should align with the business objectives. Data preparation and preprocessing. The quality of an AI system is heavily dependent on the quality of the data that is used to train it. Therefore, it is critical to ensure that the data is clean, relevant, and representative of the problem domain. This involves preprocessing the data, which may include cleaning, transformation, normalization, and feature selection. Data preparation and preprocessing are essential to ensure that the data is suitable for use in an AI system. This stage involves a range of tasks, including data cleaning, where missing or incorrect data is removed or corrected, data transformation, where the data is transformed into a suitable format for the AI model, and normalization, where the data is scaled to ensure that it is suitable for use in the model. Feature selection is another critical task in data preparation and preprocessing. This involves identifying the most important features in the data that are relevant to the problem being solved. This is essential to ensure that the AI system can learn the patterns and relationships in the data effectively. Model selection and design. Once the data has been preprocessed, the next step is to select the appropriate model for the problem at hand. There are many different types of AI models, each with their strengths and weaknesses. The choice of model will depend on the problem domain, the input and output data, and the computational resources available. Model design is also an essential task in AI engineering. This involves configuring the model to optimize its performance on the problem being solved. This may involve adjusting the model parameters, selecting appropriate hyperparameters, and defining the model architecture. Training and validation. The AI model must be trained on a large dataset to learn the patterns and relationships in the data. The training process involves adjusting the model parameters to minimize the difference between the predicted output and the actual output. Once the model has been trained, it must be validated on a separate dataset to ensure that it generalizes well to new data. This helps to identify and correct overfitting, which occurs when the model is too complex and learns the noise in the training data rather than the underlying patterns. The training and validation stage is critical to the success of the AI system. It involves a range of tasks, including selecting an appropriate training algorithm, selecting a suitable optimization method, and determining the appropriate number of training iterations. Testing and evaluation. After the model has been trained and validated, it must be tested on a new dataset to evaluate its performance. The testing process involves measuring the accuracy, precision, recall, and other metrics that are relevant to the problem domain. The results of the testing are used to identify areas for improvement and to guide the selection of the best model for deployment. The testing and evaluation stage is essential to ensure that the AI system is effective and accurate. This stage involves a range of tasks, including selecting an appropriate evaluation metric, selecting a suitable test dataset, and determining the appropriate testing procedure. Deployment and monitoring. The final stage of AI engineering is deployment and monitoring. The deployment stage involves integrating the AI system into the business process or application. This involves configuring the system to work with the existing infrastructure, such as databases, web services, or other software systems. It also involves ensuring that the system is scalable, reliable, and secure. The monitoring stage is critical to ensuring that the AI system remains effective and accurate over time. This involves monitoring the performance of the system, the quality of the input data, and the accuracy of the output. It also involves detecting and correcting any issues that arise, such as changes in the data distribution or changes in the business process. To monitor the system, key performance indicators, KPIs, should be defined that measure the performance of the system. These KPIs may include accuracy, precision, recall, and other metrics that are relevant to the problem domain. The KPIs should be monitored regularly, and alerts should be set up to notify the relevant parties when they fall below a certain threshold. Ethics and governance. AI engineering also involves considering the ethical and governance implications of the system. This includes understanding the potential biases that may be present in the data or the system, and taking steps to mitigate them. It also involves ensuring that the system complies with relevant laws and regulations, such as privacy and data protection laws. Ethical considerations should be built into every stage of the AI engineering process, from problem identification to deployment and monitoring. This involves considering the potential impact of the system on stakeholders, including customers, employees, and society at large. It also involves ensuring that the system is transparent, explainable, and auditable, so that stakeholders can understand how it works and how it makes decisions. In addition to ethical considerations, governance is also critical to ensuring the success of the AI system. This involves ensuring that there are appropriate controls and oversight in place to manage the system, including managing access to data and ensuring that the system is secure. Conclusion. In conclusion, AI engineering principles provide a framework for designing, building, and deploying effective and accurate AI systems. These principles involve a range of tasks, including problem identification and formulation, data preparation and preprocessing, model selection and design, training and validation, testing and evaluation, deployment and monitoring, and ethics and governance. AI engineering is a complex and challenging field that requires expertise in both AI and the problem domain. By following these principles, AI engineers can ensure that the systems they build are effective, accurate, and ethical, and that they provide value to stakeholders. Thank you for watching our video. We hope you enjoyed it. As a reminder, please don't forget to subscribe, like, and leave a comment on the video. Your support and engagement helps us continue to create high-quality content using artificial intelligence. We appreciate your interest in our work and look forward to connecting with you in the future. See you in the future.